Kia ora Year 11. This is video 3 with some MCAT problems. This one's got a few more simultaneous equations questions. The first one is a pretty silly question about a company that makes plastic ducks, right? So I'm going to use a yellow pen for the ducks. Right, so the total cost P dollars of making N plastic ducks is given by this formula here. P is equal to 2A plus BN, right? So I think this is the hardest part of this question, is that it feels like we have a lot of variables, right? We've got the total cost P and we've got N plastic ducks in here. And that's really important that we understand that part of it. And A and B are some fixed numbers. So then we're told the cost of making 140 plastic ducks is $580, and the cost of making 200 plastic ducks is $640. So what we're going to do is, in that first one, the number of plastic ducks that we're making is 140, so N is 140. And in the second one, N is equal to 200. And once you understand that, then we can put this information into that equation, and we can solve simultaneously. We can get A and B, and then we can use that to work out the cost of making 300 plastic ducks. Okay, so here's the question done a little bit bigger. We can write two equations, right? So for 140 ducks, we can say that 580 is equal to 2A plus 140B, right? Because N is 140. And for the second sentence, it costs $640 to make 200 plastic ducks. And then you can see that we've got a pretty clear setup for doing the elimination method, because we've got two equations and the 2A matches with the 2A. So I'll make this equation 2 and this equation 1. We can subtract equation 1 from equation 2. Right, so what we're doing when we do that is that we're saying that we know that 580 is equal to this, and we know that 640 is equal to this. And that means that the difference between 540 and 680, which is $60, must be the difference between the right-hand side of the two equations. So we get 60 is equal to 60B. That gives me B is equal to 1. We can take that and we can now substitute that back into either equation. I'm going to chuck it into the second one. That tells me that 640 is equal to 2A plus 200 times 1, which gives me 440 is equal to 2A. A is equal to 220. So now to work out the cost of making 300 plastic ducks, all I have to do is to say P is equal to 440 plus 300 times 1, right? So what I'm doing here is I'm saying the formula is 2A plus B times N. And we've worked out what 2A is, and we've worked out what B is. So the price is equal to $740 for 300 ducks. Now let's look at how we could have done that with a lot less algebra. This is in the MCAT, and so I think the instructions pretty clearly say you must solve some equations. Let's just have a little think about what's going on here. Well, it's pretty easy to see without doing any algebra that you've got 60 extra ducks and it's cost you $60 extra. So that shows you that the cost of each extra dollar, each extra duck is $1. And from there, you can reasonably easily back out what this fixed cost must be, right? Because we know that for 200 ducks, we must have spent $200 in this part of the equation. So we need to get to 640, so it must be 440 here. And that means that we could go straight to 300 ducks being 440 plus 1 times 300 equals $740. And I know there are a couple of you in class who would probably rather do it that way. I've done it using simultaneous equations because in the MCAT, I'm pretty sure you used to get told you had to use equations. But secondly, it's really good practice for you all to be confident with setting up equations from word problems. So there you go. Okay, let's look at the second question. This one is about painting lines on a field. So Billy has been painting some straight lines on a field for her netball team to do some training exercises. And we're given a couple of facts. We're told the total length of all the painted lines shown in the diagram below is 16 meters. So this one here is X, and we've got 3 of those. And then we've got a line down here, and we've got another line down here. They're very straight lines. So that shows me that I've got 3x plus 2y, and that's equal to 16. And we're told that the area is 10 meters squared. So the area of a rectangle is the length times the width, so x times y is equal to 10. And as soon as you see that, you should realize that doing substitution is going to be the easiest way to go here. There are a few choices about what we do, and we actually end up having to solve a quadratic. So my job here is to figure out what are the possible values of x. Okay, so here's how I did this one. I looked at the first equation and I said 2y is equal to 16 minus 3x. That gives me y is equal to 8 minus 3 over 2x. I'm going to take this and I'm going to substitute it in here, and I can see a quadratic coming. So I get x times 8 minus 3 over 2x is equal to 10. Expanding gives me 8x minus 3 over 2x squared is equal to 10. Now, by this stage in the year, we should know that if we want to solve a quadratic, we're going to need to have it equal to 0. And then in year 11, my only strategy is to factorize it. So we get 0 is equal to 3 over 2x squared minus 8x plus 10. I'm not liking that 3 over 2 at all. So I'm going to multiply both sides through by 2. That gives me 0 is equal to 3x squared minus 16x plus 20. Now I can factorize this. Let's have a look. I might have to do the grouping method, but I might be able to get away without it. I'm going to have a 3x here and an x here. I've got to have a plus here and a minus here, so my pattern will be minus, minus. And then I think I'm just going to try a couple of things. So factors of 20, let's think about 1 and 20. 20 and 1, that's not going to work. What about 2 here and 10 here? That's not going to work, but 10 here and 2 here is going to work out perfectly. Right, so I've done that using guess and check. You could also do it using the grouping method that we've learned in class. Let's check that it works. I've got 3x squared minus 10x minus the other 6x plus 20. So that's looking good. Right, so the last step here is to solve each of those. We have 3x minus 10 equals 0, or x minus 2 equals 0, 3x equals 10, x equals 10 over 3, or x equals 2. So that's saying that there are 2 possible values for the width of that netball field. Now we need to go and find out what the matching y value is. So we had y is equal to 8 minus 3 over 2x. So in this case we get y equals 8 minus 5. So y, is that right? Let's see, what have I done? I think I've done something wrong. Oh no, that's right, 8 minus 5. Yep, 8 minus 5 is 3. So, but I'm only asked for the x value. So I think I'm finished. X could be 2 meters or x could be 3.33 meters. So 10 over 3 meters, it's better, I think, to write it as 3.33 meters to 2 decimal places. There we go. Right, I think that's quite a hard question with the quadratic popping up in there. Well, not hard, but you just have to be very confident with all of your quadratic skills. I think there are a few people in my class who probably would have a bit of a freak out moment when they found that 3/2. Just remember that we can clear out any fraction by doing the same thing to both sides of the equation. So the step in here where I times by 2, it's easy to see that I'll still have 0 here. The place that people are going to go wrong is that they forget to multiply those two terms by 2 as well. All right, let's look at the last one, which I think is a really nice question because it links into graphs of quadratics. Okay, the diagram below shows the sketch of part of the graph of this parabola. So y equals ax squared plus bx plus 2. And that should look pretty familiar, right? It's a quadratic, and we haven't been told A or B. We've got 2 points on the graph. One has coordinates -1, 13, and one has coordinates 4 and 18. And we have to find the values of the numbers A and B. Okay, so we can substitute in. 13 is the first y value. 13 is equal to A times the x value plus B times the x value. Whoops. All right. Now I said A times the x value. It's A times the x value squared, right? Remember my equation is ax squared plus bx plus 2. That gives me 13 is equal to A minus B plus 2, which gives me 11 is equal to A minus B. So that's my equation from the first point. Now we're going to do something for that second point. So substituting in gives me 18, the y value, is equal to A times 4 squared plus B times 4 plus 2. 18 is equal to 16A plus 4B plus 2. 16 is equal to 16A plus 4B. Now, I could leave it like that, but because I've got a common factor here of 4, I'm going to divide through by that, and I get 4 is equal to 4A plus B. So that's my second equation. And you can see now we're going to solve simultaneously. I'm going to rewrite them in our usual format. So A minus B equals 11. 4A plus B equals 4. Spot the matching negative B and plus B. That makes it a nice, easy sandwich together one. So I'm going to add equations 1 and 2 together. That gives me 5A is equal to 15. A must equal 3. Substituting that into here, 3 minus what is equal to 11. B is equal to -8. Okay, so we've figured out our A and B values, and I think that's all we had to do for that question. Yep, find the value of the numbers A and B. So there you go, 3 more excellence questions from old MCAT papers with quite a range of different stuff in there. The next thing I'm going to do is some more exponentials, and then I'll get into the rearranging problems. Thanks for watching. If you've got any feedback, just send me an email.